So let's go ahead and finish up lesson 2.1. Quadratics. Where are we? We're at the bottom of this page here. So this is going to be pretty similar to the last question that we did on Friday, where we have a quadratic given to us in standard form over there. Well, when I say standard form, I mean it's not in vertex form. It's written out as standard polynomial. It says use vertex form of the quadratic function to find the vertex and the axis of the graph. That means the axis of symmetry. And it says and to rewrite it into vertex form. Well, that is no different from what we did on Friday, except there's something wrong with the way this quadratic has been written. You guys see it? It's not actually in standard form. It's not in standard form because it's not in the correct order. In order for a polynomial to be in the correct order, the exponents must count down from biggest to smallest to usually none. So yeah, this thing's out of order. Let's start by writing it in the correct order. Negative 3x squared plus 6x minus 5. There. Now we can do what we did on Friday. We're going to complete the square. And just like on Friday, we don't want that number sitting in front of our x squared. You can't complete the square easily with a number sitting there. So what we're going to do is we're going to factor that number off of the front two terms. Remember, when you divide by a negative number, it changes your sign. So it's not going to say plus 2, it's going to say minus 2x. And there will be a magic number that we find right there that will complete the square for us. So first, we figure out what our b term is, and we cut it in half. And when we say what's the b term, I mean inside the parentheses. After you've pulled out the, I don't know if I want to call it a greatest common factor, but the whatever number's in front of x squared. So after you pull that out, you're looking for here. This is your b term. So we have negative 2 divided by 2, which is negative 1. That number is important because when we complete the square, if we do it appropriately, that number negative 1 will be what's inside the parentheses. And the c term is found by squaring that number. So whatever number you found, square that bad boy. And negative 1 squared is positive 1. But you are not allowed to just add a number to a side of an equation. Typically, you would have to add something to both sides. We talked about this last lesson. But since we're trying to get f of x by itself, if you did add, quote unquote, to the right side, you'd have to add to the left side, and you'd have to subtract it back over. The point is, whatever you do here in red, you have to make sure you cancel it at the exact same time, ensuring that you haven't actually altered the equation. It looks like I've added 1, but I haven't. What have I actually put on this side of the equation? Negative 3. Someone whispered it. A negative 3, and the reason why is because if you were to distribute this negative 3 to this plus 1, there would be a new minus 3 on this side of the equation. We have to make sure that we cancel it at the exact same time. So if that's a minus 3, then it needs to also be a plus 3. So now if you were to distribute that negative 3, you would have a minus 3 and a plus 3 on the same side. They'd cancel each other. They'd be gone. And you have technically done nothing. It's a whole lot of stuff to do nothing, isn't it? It's a lot of math to actually have done nothing.
A whole lot of stuff for a whole lot of nothing.
A whole lot of stuff for a whole lot of nothing, exactly. It's kind of funny to say, to make sure we did nothing. But that set of parentheses now, x squared minus 2x plus 1, is a perfect square trinomial, and it will factor to a set of parentheses squared. X in the front, and then, like I said, this number right here will go right there. And then on the outside, negative 5 plus 3 is negative 2. So that is vertex form, and we can now figure out what the vertex is and the axis of symmetry. What is our vertex? Well, our vertex is going to be at what makes the inside equal 0, comma the number to the far right. So 1 comma negative 2. Our axis of symmetry then is x equals the exact same number that we had for x for the vertex, because the axis of symmetry will always go through the vertex. And that's all we were supposed to do, right? Yeah. There it is.
Does it ask for the axis of symmetry?
Yeah, it does. It just says the axis of the graph. That means axis of symmetry. I think the authors were just being a little bit lazy when they said axis of the graph. There you have it.
Writing that requires more effort than axis of symmetry.
I guess. The symmetry is hard to spell, though. Yes, sir. What can I do for you?
So we have to multiply the inside of the 1 by the negative 3. What is it?
So the reason why I have a +3 on the outside, because you're used to usually a minus out there, correct? Imagine you were to have distributed this -3. You'd have -3x squared plus 6x, and then there'd be this new -3. You have to make sure you cancel it.
Oh, okay.
So I have to have its opposite on the outside, and that's why there's a plus out there now. So yeah, you just have to make sure that you have the opposite of whatever you would have if you were to have distributed the -3. You just make sure you use your opposite number on the far right side to cancel it out.
Wait, so are all graphs going to be able to do this, or only some?
You mean, could I complete the square for any quadratic?
Any?
I could complete the square for any quadratic. Now that doesn't mean that the results would be pretty. There would be usually a lot of fractions, maybe some radicals here or there. I mean, like, yeah.
We're not going to.
You mean I'm not going to make you do that? No, I'm not. However, I could do that. Has anybody ever seen where the quadratic formula comes from? You ever seen it derived? Well, I could do it after the lesson if you'd like. The quadratic formula is actually the result of taking standard form of a quadratic, y equals ax squared plus bx plus c, no numbers, and completing the square. If you complete the square on ax squared plus bx plus c, what you get is the quadratic formula. If you were to then solve for x. It's pretty neat. I can show you after the notes. By the way, that's an Algebra 1 standard for the state of Florida. Algebra 1 students are supposed to be able to do that. As people look at each other like, yeah, good joke, bro. Yeah, I agree, but I'm just letting you know. It is an Algebra 1 standard. Can I clear this without anybody panicking? We're all good here? Clear. And on to the last page. It says find the equation of the quadratic function that has vertex -3, 2 and some other point P 5, -2 on the graph. All right, no big deal. No big deal. Did I do this in vertex form? I did. F of x equals a times x minus h squared plus k. So here is vertex form of a quadratic. Our vertex, which is given to us, is always going to be h comma k. So our h value is -3 and our k value is 2. Hold on, I swear I can write. I promise I can. Here's an h, here's a k.
Are you sure?
Sometimes I'm sure, but I don't know. Today, I don't know. But yeah, so since we know this h and this k, we can just plug these numbers in. So let's start there. We don't know this a term. And here we have x, and we normally would say minus h, but h happens to be -3. So you'd be saying x minus -3. So that's going to give me x plus 3, and plus our k value of 2. There. Well, I have everything I need except for that a value. That stretch or shrink on the front, possibly a positive or a negative number, who knows? We need to be able to find that number. And we do that by using the only other information that was given to us, this x comma y that was given to us. So if we plug in x equals 5 and y equals -2, we will be able to solve for a. Make sense? Yeah? Okay. So let's plug them on in. My y value, -2, equals a times my x value, 5, plus 3 squared plus 2. All right, negative 2a, what is that, 8 squared? 64, so let's write 64a plus 2. Subtract 2 from both sides, you'll get 64a equals negative 4, and then divide both sides by 64. Now we don't want a decimal because it's probably not pretty, but a happens to be negative. 4 over 64 reduces to 1/16, so negative 1 over 16. So we can write our answer. F of x equals negative 1 over 16 x plus 3 squared plus 2. Boom, there it is. You know what's actually really interesting about quadratics, what's really interesting to me, is you could take any 3 random points that you can think of, just throw them at an XY grid, and there is a quadratic that goes through all 3 of those points every single time. Any 3 points you can imagine, like I say, you just take 3 marbles, throw them at a wall, blah. As long as they're not vertical from one another, because that's not a function, right? As long as they're never vertical from one another, there is a quadratic that will go through all 3 of them. It's really cool. But if I give you the vertex, life is good. Life is easy, right? You just plug in the other x comma y and solve.
Life is good.
Life is good, all right. Then we move on and we talk about free fall motion. Guess
Life
what?
is no longer good.
Yeah, word problems, right? Life was only good for a split second. Look, gravity is modeled really, really well by a quadratic. Now we do have to imagine there's no air friction and things like that. You know, can't just suspend belief. I mean, you know, clearly that paper didn't fall at the speed of gravity, but that's because there was air friction getting in its way.
You put it in a vacuum, everything falls at the same rate of speed.
Exactly.
Be it feather or bowling ball.
Exactly. In a vacuum, everything's going to fall exactly the same rate, and that is due to gravity. So what we have here is 2 equations, and these 2 equations, if you're a physics student, you've seen these before, maybe with different variables. But
We need to have those written down.
Do you mean you have to have them memorized?
Yeah.
No, you don't have to have them memorized. If I need you to use them, I will give them to you. I'm not going to ask you.
Okay, thank
Yeah.
you, because I really didn't want to. Those are
Yeah,
really
in physics,
complicated.
if it was physics, you would have to memorize them, but this isn't a physics class. So the height, s, and the vertical velocity, v, of an object in free fall are given by these 2 equations. You see I've got a g there and I've got t. G is going to stand for gravity, and we are going to use either 32 feet per second squared, and that is in imperial units, hours, here in the States, or 9.8 meters per second squared for the rest of the world. T is time in seconds. And then we have this weird v sub 0 going on right here. That means velocity when the 0 time has passed, so initial velocity. And then this s sub 0 means, remember s is height. Height when 0 time has elapsed, so your initial height. So how do you decide whether or not you should be using 32 feet or 9.8 meters? Well, whatever units the word problem is asked in. If the word problem is asked in imperial units, or what people like to call standard units, that would be our system, feet and inches and things like that. If it's asked in meters or millimeters or anything like that, obviously you're going to be using metric. So let's see what we have going on.
Those 2 numbers.
What's that?
Yeah. Do we need the 32 feet per second and the 9.8 millimeters per second memorized?
If I needed you to, no, I'm not going to ask you to memorize those. Again, if I needed you to do it, I would just tell you that kind of stuff. If it was a physics class, you would have to have them memorized, but it's not physics. So let's see what we got going on. A rabbit is fired from a small cannon on a tabletop. First of all, obviously that was not written in your textbook, rabbits being fired from cannons. But the reason why I put that in my notes is I'm paying homage to my Algebra 2 and AP Calculus teacher, Mr. Bluebaum. You know, Mrs. Bluebaum teaches AP Calculus. Mr. Bluebaum was my Algebra 2 honors teacher, my Calc 1 teacher and my Calc 2 teacher, and he loved firing rabbits out of cannons. So all of his problems like this were always a rabbit is fired from a cannon. So I put it in my notes. A
Were
rabbit.
rabbits alive though?
I don't know. We're not going to talk about whether or not that rabbit survived because that's dark. Anyway, a rabbit is fired from a small cannon on a tabletop straight up into the air with initial velocity. Oh, that's V sub zero. V sub zero of 120 feet per second. Okay, we're using imperial units here. From a height of 4 feet. That's the height of the tabletop, I would assume. So that is going to be your H sub zero. H sub zero. I'm sorry?
You mean S? Is S the height?
Yeah, stupid H and S. Okay, my S's look like 5s. I'm going to do my best. S sub zero. Yeah, that's not too bad. It says find equations that model the height and vertical velocity of the rabbit t seconds after it's fired. Okay, well that just means plug in the values that were given to you. And since we are in imperial units, we will be using the 32. So S sub t, or S of t, excuse me, is -1/2 using the 32 t squared, and then plus V sub 0, 120 t plus S sub 0, so plus 4. And what's the other one?
That E and that's a plus sign right next to it.
That's why I curved the bottoms of my t's. That way they don't look like plus signs. And the other one is V of t equals negative. The value that we're going to use for gravity here is 32 again. And then plus V sub 0, which is 120. Okay, well that one's written. But the one on the left, we've got to clean it up just a little bit. S of t is -16 t squared plus 120 t plus 4. There. S of t and V of t.
So if we were to get a question like this on the test, we would have the equations above it, right?
Right.
Or
I would give you the generics with the V sub zeros, the S sub zeros, and the G in it. Yes. If I was asking,
Okay.
yeah, I'm not going to ask you to memorize those equations. For me, I want to know, can you use them appropriately? For physics, you know, Mr. Case, who was my physics teacher, would have us memorize these things. So, but this isn't physics. This is mathematics.
Ouch.
The 16, it's just half of 32. Yes? No? Is that okay or no? Okay. So that was A. Let's see, part B. Part B says, what is the max height the rabbit will reach, and how long will it take to reach that height? Well, we know we're talking about heights, and our S of t is our height. So we're talking about the parabola there. Let me ask you guys, on a parabola, where would I find my maximum? The vertex. Yeah, so we're just looking for the vertex. It says, what is the maximum height? That's the y value of the vertex. And how long will it take? That's your t value of the vertex. You're just looking for your vertex. Well, your vertex is going to be found at t equals, not x equals, t equals -b over 2a, because this is in standard form. Normally, that would be x equals, right? But t is our variable right now. So -120 over 2 times -16. -120 over -32. I don't think that's going to be pretty. It's not. It comes out to 3.75. At least,
3 and 3/4.
at least it's a pretty decimal, right? And obviously you would have a scientific calculator on the test. Not a graphing calculator, but yes, a scientific.
Oh, do we need the scientific?
Anything has to do with that would be cruel.
Yeah. What's that? What do you need? What's that?
We need a scientific for this book.
Oh, well, no. Well, I mean, if you don't have a scientific calculator, I have them. Remember, I had them on top of the laptop cart. Was that with you guys, or did we test them? We did? Yeah. Yeah, I'll provide you with scientifics if you don't own one. It's not a big deal.
You let me use graphing calculator.
Yes, in the SAT you can use a graphing calculator.
And I'm thinking that we can
Okay, so this t, we found the how long will it take. That's what we found. We haven't found our maximum height. In order to actually find that maximum height, unfortunately, I'm going to have to plug in that 3.75. So at least we know that's how long it's going to take to get there. So what is S of 3.75. So you would definitely be grabbing handy dandy calculator for this one. Negative 16 times 3.75 squared. Make sure you use your parentheses when you're typing this on your calculator. Because it will follow PEMDAS for you if you use parentheses. And that comes out to 229 feet. Dang, rabbit. Flying. 229 feet. I doubt it survived.
It could have landed in the pool.
Well, yeah, it could have landed in a pool until we read part C where it says, how long until the rabbit lands safely on the ground? Oh, well,
Safely.
I guess we were being kind to old Fuzzy, weren't we?
It has a parachute.
Parachute,
Let's just assume
maybe.
It has a parachute.
You
Or
mean,
it was dead when it came out.
We're
Or
gonna-
a stuffed rabbit.
we're gonna have to hope it has a parachute. Okay, how about
Or a
this?
stuffed rabbit. Stuffed rabbit would be fine. Doesn't say it's alive.
Dang, that's dark. So C,
A stuffed rabbit isn't dark. Excuse you.
it wants to, let me ask you guys a question. If I'm talking about how long until it hits the ground, what am I actually asking you to find?
Set it equal to 0 when its height is 0.
Right, set it equal to 0. That's because your height will be 0, and Max says that will be an x-intercept. Exactly. So let's just talk about this for a moment. When the rabbit was initially launched, and I didn't draw this picture in my notes, but when the rabbit is initially launched, it's on a tabletop, right? So imagine, boom, rabbit comes up out of this cannon, it's started on a tabletop, and eventually hits the ground. Has parabolic motion. That means there will be a positive x-intercept somewhere.
Or thumper.
But there would also be, the other direction, a negative x-intercept or t-intercept for this example. So in a real-world question like this, you will probably always get a positive x-intercept and a negative x-intercept. And the negative x-intercept is the kind of thing that you just have to know is impossible. We don't have time-traveling rabbit here, so negative times won't make sense for us. But yeah, we're just going to set it equal to 0 and solve for t. So 0 equals, no time-traveling rabbits allowed. Negative 16t squared plus 120t plus 4. Yeah, it doesn't factor. So you could either use a quadratic formula or a graphing calculator to get t is approximately 7.533. So on your homework, I expect you to either use Desmos or your graphing calculator to find this x-intercept. What that means for you is on a test, just think about it, I can't ask you to do this because I'm not going to give you a graphing calculator. I could ask you to do part B with a scientific, but I'm not going to ask you to use a quadratic formula with these big old numbers. I'm just not going to. I mean, I could, but I'm not going to. Because
You're me, but not that man.
Exactly. That's why I'm telling you on your homework, use Desmos or graphing calculator technology. Let's see, the last part of the question says, what will its vertical speed be at that moment? Well, that's just v of t. So all we have to do is plug in t equals 7.533. So our vertical speed when time is 7.533 is negative 32 times that number, and then plus 120. And I'm going to assume that everybody in the room knows how to use a calculator. It gives us negative 121.056 feet per second. Old Fuzzy is moving.
How's he going backwards?